Hello and welcome to PCMINR.com, and you're watching this video on Solve Problems on Laws of Motion by Sonal Gupta. So a question asks, a man of mass 70 kg stands on a weighing scale in a lift which is moving upwards with a uniform speed of 10 meters per second, and the second case when it is moving upwards with a uniform acceleration of 5 meters per second square. So you have to find out the readings on the scale in each case. Now first, when your lift is moving up with a uniform speed of 10 meters per second, that means in A your acceleration is 0 because it is moving upward with a uniform speed, and so the acceleration would be 0. The mass of the man is 70 kg. So what would be the equation of motion as per Newton's second law of motion? So from Newton's second law of motion, the net force in the upward direction, how do we get that? The upward force, that's reaction of the man as a result of its weight mg downwards, is equal to ma, the net force in the upward direction. But r minus mg would be equal to 0 because my a is 0. This gives me r is equal to mg. So the reaction is equal to the weight of the man, and that is equal to 70 times 10, which gives me 700 Newton as the reaction. Therefore, what is going to be the reading of the main scale, of the weighing scale? So reading of the weighing scale is actually equal to the reaction. So reading of the weighing scale would be equal to this reading 700. We have to divide it by g to get 70 kg as the mass of the man. So reading of the weighing scale would be exactly equal to the mass of the man when it is moving up with a uniform speed of 10 meters per second. Now let's look at the second case. So when the lift is moving up with a uniform acceleration of 5 meters per second square, so the equation of motion as per Newton's second law. So Newton's second law gives that your upward force, that's reaction again, minus the downward force, that's the weight of the man, is going to be equal to m times a. Now reaction is going to be equal to m times g plus a. Now m here we have is 70 times g, we will take g here as 10. So 10 plus 5 meters per second square, it's given here, acceleration is 5 meters upwards. So we get 70 into 15, and that gives me a value of 1050. So 1050 Newton is the reaction. Therefore, the weighing scale is going to measure, the reading on the weighing scale gives a reading of 1050 divided by 10, that is g, so 105 kg. That means when the lift is moving upward with a uniform acceleration of 5 meters per second square, the weighing scale is going to give you a higher reading than the actual weight of the man. I hope you find this video helpful. Please like us, subscribe us, and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.